Hello, everyone, and welcome back to Math Zone African Motives. So, I want us to continue as agreed, as we promised each other. We move on to practice questions. So, what we have been doing so far, we've been looking into a topic that is examinable both in grade 11 and in grade 12. So in grade 11, this is where you would actually get introduction and also dive deeper into this topic. And then in grade 12, this is where you are required to do what we call revision. So what we have been doing, it's a recap of what we have done in grade 11 so that we can catch up as we are now in grade 12, so that when it comes to exam questions, this topic that you term forces and Newton's laws of motion, you will always find it on question number 2 after your multiple choice question. So this question is always on question number 2. So you need that knowledge from grade 11. Hence, I've decided that we actually start by diving deep into its revision and do some practice questions so that we can do some brain recap, so that when we start doing momentum and impulse as well as projectile motions as we move on, we have refreshed from everything that we are supposed to be knowing from our lower grades. So without wasting time, I've brought you two exam questions from two different question papers from two different provinces. They are all question number two, but from two different sets. So this first question was saying two blocks of masses, which is 4 kg and 8 kg respectively, were connected by light inextensive string, which is the 4 kg block and the 8 kg block from the diagram. And then a second light inextensive string was attached to block 4 kg. This string that runs over a frictionless pulley. So you would see that this block runs over the frictionless pulley, and then a constant horizontal force F pulls the second string as shown in the diagram. A constant horizontal force F, it pulls this over the frictionless pulley. So they are saying the magnitude of the tension between the two blocks, the tension due to this string is equivalent to 120 Newton. And then they're saying ignore the effects of air resistance. Now, they are saying state Newton's law of motion in words. We said that Newton's law of motion in words states that if a net resultant force is applied to an object, the object will start to accelerate in the same direction as the applied force. The acceleration uh, the magnitude of the acceleration, let's just say the magnitude of the acceleration to save time and space, the magnitude or else the size, the magnitude of the acceleration is directly proportional to the applied net resultant force, to the applied net resultant force. but inversely proportional to the mass of the body. Mass of the object. So by formulation, we get to say that if a net force F net is applied to a body, let's say this is our body and we apply a net force, you would see that this body will now start to accelerate in the same direction. It will now start to accelerate. It will have an acceleration that is in the same direction as the net force. And that magnitude of that acceleration will be directly proportional to the what? To the magnitude of the applied force, but inversely proportional to the mass. That is what they wanted you to state in words. So that is how you would have stated in words. Now, they are now saying draw a labeled free body diagram showing all the forces acting on the 4 kg block. This is the 4 kg block. If that is the 4 kg block, we can see that we have got this applied force F that is pulling the block up, and then the weight of the body due to this mass. So we have the weight. After the weight, we have got this tension which is within the rope. So that is what we want to represent in a free body diagram. I'm going to have the applied net force, or else the force that is applied, and I'm going to have my tension. After having my tension, I'm going to have my what? My weight. So that is what you were just expected to do in terms of drawing a free body diagram. And usually the magnitude or the size, the number of marks determines the number of forces that you have to represent that are acting on the body. After that, they were now saying, calculate the magnitude of force applied on the system when it is accelerating. Now, for us to find that force that is applied, which is F here, I want us to adopt a certain system. So allow me to rub here so that I can actually get to write down. I want us to adopt that system and I want us to use the diagram. Hence, I'm rubbing so that we can be near the diagram. I would have used the other space, but I just want us to be near the diagram. So, first and foremost, we have to look into forces that are acting on the 4 kg block and also look on the forces that are acting on the 8 kg block. And then we determine the net force that is acting on 8 kg and also the net force on 4 kg. That is the only way we can be able to later determine the applied force when the objects are now accelerating. So now let's start by the what? By the 8 kg block. So we are going to look on the what? On the forces acting on the 8 kg block. So you can see that we are going to have a net resultant force due to Newton's second law, which will be given by MA. And then that net resultant force is equal to the sum of all vector forces. Now the sum of all vector forces on the 8 kg block, I've got weight going down, which is given by mg. And then I've got the tension, which is going up. So if I choose up to be positive, I would certainly have my tension being positive and then my weight being negative. So I would come and say this is the 8 kg block. My mass would be 8 times my acceleration. Then this is actually going to be equal to my tension minus, I've got 8 times 9.8. And then certainly my tension is 120 newtons minus this 8 times 9.8. It is going to be equal to what? 79.2. And then this side I've got 8a. If I now want to make a the subject of the formula, I would divide by 8 throughout. because that is the only unknown that I have here, so that my acceleration here of these bodies, when they are now accelerating, it will be equal to what? I would say that divided by 8 here I'm supposed to say what? 120 minus 79.2 divided by, yes, 120 minus 79.2 divided by 8. That will give me 5.2. That will give me what? 5.2. So this is 5.2 meters per square second. So just punch in your calculators and cross-check and confirm these answers. Now that I've used the 8 kg block to find the acceleration, then I'm able now to use the 4 kg block to find this force. So I would say forces acting on the 4 kg block I now need to look. So on the 4 kg block, I can see that I also have got this tension. I've got that weight. I also have got that force F. So here I would have my net force is the object to be accelerating given by mass times acceleration, which is equal to the summation of all vector forces, which is equal to, if I choose up to be positive, I'll say this F minus this T minus W. So here I would be having 4 times acceleration. This is the mass of the 4 kg block. And then the vector forces I would be having what? F minus my tension is just 120. My weight would be equal to 4 times 9.8 because I'm now taking mg here. The mass is 4, the g is 9.8 meters per square second. After that, I would be left with F minus, I have got 120 minus 4 times, actually I have to add up these. That's 4 times 9.8. If I add these ones, I'm supposed to get 159.2, 159.2. And mind you, the acceleration, we said it's 5.2. So I'll take this one, that other side, so that it becomes 4 times 4.5 plus, because I'm now transposing to make this the subject. 159.2 should be equal to F. If I add those, I'm supposed to get 180 newtons. So my applied force there is this object will be now accelerating was going to be equal to what? 180 newtons. So that is how you would have determined that force. So you first look on the forces that are acting on the 8 kg block. You then look on the forces that are acting on the 4 kg block. We can either start with these forces or start with those forces. But I just chose to start with the 8 kg block because this is where I've got almost all the information that I can use to find only one unknown. And then substituting that unknown to the other one, I can be able to solve for whatsoever that I need. So here F, which is the F applied, was going to be 180 newtons. Now let's look on the second question. The second question is now saying 2 blocks of masses 5 kg and 3 kg respectively are connected by a light inextensive string that runs over a frictionless pulley as shown in the diagram below. The 5 kg block experiences a frictional force of 8 newtons. So here, due to the roughness of the surface, we have got a frictional force of what? 8 Newton. And then the coefficient of kinetic friction on the 3 kg block is 0. This is mu k here, which is 0.15. Now they are saying that define the term frictional force. Frictional force is just, this is the opposing force of motion. This is the opposing force of motion. On our first video, we defined all types of forces, and we said that the frictional force is that force that opposes the force of motion. So the opposing force of motion is our frictional force. Now, this opposing force of motion, we know that it can be given by mu times our normal force. Now they're saying draw a labeled free body diagram to indicate all the forces acting on the 3 kg block. You would see that now on this 3 kg block, due to its orientation, I would be having a normal force inclined here. I will be having a normal force that is inclined here, which is due to this surface. So this normal force will be here. And then I would be having the weight due to that mass that is directed downwards. And then due to the roughness of the surface, which is this surface, I would be having my frictional force. So a free body diagram will just take these forces and draw it on a free body diagram. I would be having my dot representing a free body, my body there. And then this would be inclined. That is my normal force, my weight going downwards, and then my frictional force inclined like that. So that is what we're just supposed to do there. But someone would have came and resolved these forces into different what? Into their different components. This force, the weight force, as it is going downward, it is on an incline. This force, you can resolve it onto a parallel weight component, or else a perpendicular weight component. By resolving it like that, you would be having your theta here, and then you would also have another theta here, so that this would be adjacent. So this would be opposite, sorry. This becomes your opposite. That becomes your opposite. That also comes to become your adjacent. So that you know that from your Pythagoras theorem, you usually use that cheat code, SOHCAHTOA, to say sine theta is equal to opposite of hypotenuse. So opposite would be equal to hypotenuse sine theta. So here my opposite would be equal to what? This is my hypotenuse, which is my weight. My weight sine theta. That becomes your parallel weight component. Your perpendicular weight component, which is your adjacent, it will be what? Adjacent side would be equal to hypotenuse cos theta. Then this one would be equal to what? W cos theta. So you would now know that if you come, you draw the parallel weight component, this parallel weight component would be given by W sine theta, and then the perpendicular weight component would be given by W cos theta. You have resolved your forces there. So someone would have just drawn it in a way that you'd be having your parallel weight component, whilst this side you are having your normal force, and then that side you are having your perpendicular weight component, and then this side you are having your what? Your frictional force. They would accept these two notations on your free body diagram. But however, because we can see that here they already indicated that the number of marks are 3. So we would expect you to draw a free body diagram that indicates 3 different forces acting on this body. Which are these forces? Now let's go to the next question. So our next question now is, it has to do with calculations. They are saying calculate the magnitude of the frictional force acting between the 3 kg block and the surface. So here we are only given this coefficient of kinetic friction, but we know that the kinetic friction on this 3 kg block can be calculated by the coefficient times the what? The normal force. But we do not have this normal force. But on our diagram, we said this normal force is balanced by the perpendicular weight component, where this perpendicular weight component is given by what? By mg cos theta, which is just weight cos theta. So we can see that since these two, they are balanced, so this is also equal to that. So the frictional force there, Fk, would be equal to 0.15, which is your what? Your kinetic coefficient, which is your frictional kinetic coefficient, times your normal force. So your normal force here would be mg cos theta, where our mass here is just what? 3 kg times 9.8 times cos 30. And then this will be multiplied by 0.15 to give us our kinetic frictional force. So by calculation, you are going to get, you'd say 0.15 times 3 times 9.8 cos 30. And that was going to give you what? That was going to give you a total of 0.68 newtons. It was going to give you a total of 0.68 newtons. So that is the answer that you were supposed to find there. That is the answer that you were supposed to find by just using this calculation. Now let's look on the next. They're saying now calculate the magnitude of the tension in the string. This is where you look onto the forces acting on this block and forces acting on that block. So I would use the space below here to say that let's first look on the forces acting on the 3 kg block, which we have already looked into. That would be F net equal to MA according to Newton's law. This is equal to the summation of all vector forces, where the summation of all vector forces, what are the forces acting on that block? We can see that we have got here, we have got a parallel weight component, and then we have got tension, we have got a frictional force. Because this block is going downward, the frictional force is acting against the motion. So these are the vector what? These are the vector sum of forces that are acting on this block along this horizontal surface, along this incline. Because the ones that are going on this one, they are balanced. The net force there is 0. That's why we said Fn is equal to the perpendicular weight component. So along this, we have got this. So we'll take downwards as positive. So this one minus this one minus that one. So that is what we are just going to write there, which is equal to my perpendicular weight component minus my tension minus my kinetic frictional force. This weight component is what? Mg sine theta minus my tension. I do not know that tension minus my kinetic frictional force. This I've already calculated, 0.68. And then here I've got a mass of 3 times an acceleration. After I've said that, I can be able to come here and be able to solve for what I can solve for. This would be 3a equal to, here I'll be having 3 times 9.8 times sine I've got sine 30 minus t minus 0.68. So here I can transpose, I can actually get to say, or else I'll leave it in this format where I solve this and that. Let's see, what is that? 3 times 9.8 times sine theta, which is sine 30, minus 0.68. Definitely that one was going to be equal to what? I would be having just pardon me there. We are saying that we want to find sine 30 and we know that it will be equal to sine 30 would just be equal to 0.5 times 3 times 9.8. That will give you 14.7. Minus so you are going to get 13.834 minus t being equal to 3a. Now I have got my first equation. I'll now go and do my second equation here, where I would actually get to say that forces on the 5 kg block, forces on the 5 kg block. I'll now come and look on the 5 kg block. What are the forces that I have on the 5 kg block? You see that on the 5 kg block, you are actually having this tension here due to the string. And then after that, you are also going to have what? You are going to have your frictional force, which is your 8 Newton that has been stated. So by that, these are the two forces that you have, and you need to find F net. You need to find F net. After that, I was just going to say F net on the 5 kg block is equal to 5 times acceleration, which is equals to sum of all vector forces, where I will take going down being positive. So this tension will be positive minus my frictional force, which is 8 newtons. So by that, I will now be left with what? 5 times my acceleration being equal to t minus 8. And then that being my equation 2. So you will see that now I now have got equation 1 and equation 2. I can copy equation 1, which is this one, or equation 2 below here, where I would say 5a is equal to t minus 8. With that now, all I need to do, this is equation 2, this is equation 1, is to solve for tension or else acceleration. So what I can do is to take this tension to say I transpose this to that side, it becomes 5a plus 8, and then I would put it here. So it will be 3a equal to 13.834 minus my tension, which is 5a plus 8. That is going to be 13.834 minus 8 minus 5a equal to 3a. I'll take this, that side. This would be equal to 8a is equal to 13.838. If now I say 13.834 minus 8, it will be equal to 5.834. So after 5.834, I can now actually get to what? Divide by 8, and I will find my acceleration. That would certainly be equal to 0.72925 meters per square second. So to find my tension, I already said tension is equal to 5a plus 8. That would be equal to 5 times 0.72925 plus 8. And this would be equal to. So I would come and add there. So my tension would be equal to what? 11.64625 Newton, or else 11.646 Newtons. So that is how I was going to find my tension. And that is how we answer it our questions. That is how we answer our questions. So that is it, guys. And these are the questions that I have brought for you for revision and at least for practice questions, so that we get used to what we are expected to be doing. So let's meet in our next classes, where now we are now going to be starting on momentum and impulse. Thank you so much, and let's meet in our next class.